This video is going to show you how you might use a GIS map to help to explore some of the different plate margins and the features that are found around the planet. We're going to maximize the potential here of the GIS map by being able to put on different layers and different pieces of information, but also look at the map at different scales. But we start off with an overview here, and I've got a layer here turned on called World Ocean Base. It's a particularly good layer because it shows the topography of the ocean floor. And the one that I want to start off with, first of all, is to turn on a layer called the Mid-Atlantic Ridge. Now, I've just put on a little section of this. I've done that through something called map notes. I'll show you right at the very end how you might add those. They're very simple. I've also put some bookmarks in here that'll take us right to where we need to go. And it identifies for us where the Mid-Atlantic Ridge is, and it allows us to come in here and have a little bit of a closer look. I can turn that layer off if it gets in the way. It allows us to get a bit of a sense of the scale of it. Let me turn that back on again. There is the Mid-Atlantic Ridge, there's the Central Rift Valley, and we can get a little bit of a sense here of the width of the entire ridge itself. These are massive features, these mid-ocean ridges, and just to give the pupils a little bit of an idea of the scale of them is something that can be done very powerfully through something like this. So that's our Mid-Atlantic Ridge. Now we can take a look at conservative plate margins. Let's move on down here a little bit, and I put on this map notes layer. One of the things I'm always keen to communicate to the students is that these conservative margins are really transform faults that sit across these mid-Atlantic or mid-ocean ridges along the constructive plate margins, and you really can see that through the map here. And the map layers or map notes layer that I've put on just allows you to turn that off and on, and you can explore that with them. There is your Central Rift Valley coming along here and your transform fault. You could take a look with them at the processes of seafloor spreading there, which means that at this location the plates are moving alongside each other. Now, next we want to go to conservative margins here in California, because this is always an interesting one for us to look at, the San Andreas Fault. Being able to look off the west coast of North America here at the complex plate boundaries that are in operation gives you an opportunity to really contextualize this in place. Here we have a spreading margin here that is bringing off this part of Mexico, and eventually will lead to much of California potentially splitting away from the rest of the United States of America. And you can go on there and have a look at that, the very famous, of course, San Andreas Fault. Then we can go on to take a look at a collision zone. Now, at any stage you want to zoom in and out to show the students where you are on the map, you can do so. But for this one, I'm going to change the base map. I'm going to turn off the ocean base map, I should say. The base map that I've selected is one called Imagery, and it shows you very, very well where India has collided into the rest of Asia, and you can see all of these foldings of that crumple zone of the collision that's taken place, and our plate margin just runs along here. Now, what I've put on in this case though is a very simplified map of geology, because this is your sedimentary rock. And that gives you an opportunity to talk to the students about that process where the seafloor sediments that are laid down are lifted up to produce the mountains here, and in that would lead, in this case, to the formation of your metamorphic rock. It's a very simplified map there showing geology, but I have a more accurate, more detailed one here, world lithology. I'll just turn that off so we can see it better. Now, there is a very, very complicated layout of the geology here, but basically if you click on those green colours, you can see that's your metamorphics, and here in your yellow colours, your sediments. So you can click on there and explore that with them. You can go in and have a really close, detailed look at how that relates to the topography. We can turn that off and on and relate it to where you can see here, as soon as the rocks are crumpled up, you're getting into that metamorphic rock that's taking place. But again, loads to explore there, contextualized within space. Now, from there, we can go on to take a look at Ocean Trench Island Arc. This is always a favourite one that I like to look at, the South Sandwich Islands, because it is such a classic example of it here. And I can turn on my layer showing where that is. But because we can be in charge of scale here, we can go right zooming in, talk to them about the fact that these islands are volcanic islands. You can use the measure tool to give you a sense of the scale of that. That island is very, very small, just 10 kilometers across. How far away is it from the trench? We'll zoom back out a little bit. And here's the measure tool again, and across the trench, and we are about 130 kilometers. But you can see here a lot of the patterns coming through, how the volcanic islands are parallel to the trench, the ocean trench island arc. We take a look at another example of that. This time we're going to go to the North Pacific, with the trench sitting here along the North Pacific, and all these volcanic islands that are occurring here. I've bookmarked one of these, Pyre Peak. We can go in, closer look. Again, if you want to just contextualize really where that is, zoom out. You can zoom right into this. You get this aerial view, and look at how beautiful that picture is. Incredible example there of the volcano and all of the details that you can see from that, from the eruption. Now again, you could explore that, any of the other islands that are there, but why don't we measure how far that is away from the trench? And we see we're about 150 kilometers, and you could even sample along there. You could get a range of them to see how consistent that distance is. You can see that it's pretty consistent there. And then we can go on and take a look at our last example, which are our ocean trench fold mountains, which are found, first of all, are a little example here, which is in North America. And I've got a layer here on world volcanoes, so I can turn that on. I can turn this layer on to show where the plate margin is. And what we can clearly see here is the range of volcanoes that are found. Now let's measure them again. How far away are they from the trench? A little bit further this time than the previous ones that we've looked at, but you can go in and take a look at any one of those. Of course, here is your classic Mount St. Helens. You can go in there and take a really good look at that. Look at the glorious detail that you've got there from that aerial view, and all the things you could look at. You can measure the distance there across the crater. You can see the impacts of the mud flows. How far away did the mud flows reach? These lahars fanning out from the center, and so on. You can measure all of those. You could look at a whole range of different volcanoes that are found there in the Cascade regions. You don't need to go too far away to spot plenty of them. And if you click on any of these little triangles above, it gives you the name of the volcano, gives you the elevation, the type of the volcano, all sorts of things like this. And you can explore how those volcanoes are related to the plate margins. And the final place that we go to here is, let's click on this and go down to South America. And you can see here very, very clearly, in many ways much more so than you can with North America, the trench and the fold mountains that are found there. That base map of the aerial photograph looking really, really well in that. And again, you can go into any one of those and you can click on these and find out about the volcano that's down there. Again, you can zoom in really close and pick up some great detail on each of the volcanoes, or any of them that you want to look at. So what you're really in control of here is the scale. You can go from the global overview to any one of those details really, really easily. And we can stick on the overview of the plate boundaries. We can tidy this up by taking those all off. And then you're able just to see all of the different plate boundaries around the world and how they relate to the different features, the volcanoes, the trenches, the ridges, and so forth. So you can see with something like this how a useful tool it will be for a teach from the front if you're going through this, to have that open on your interactive whiteboard. So whenever you talk about any of the processes, you can go on here and really contextualize this. Now, if you do have access to computers or bring your own device for your pupils, you can of course devise some tasks for this that would allow them to go and explore this themselves. Just set up a few worksheets that will guide them around. Either way, it's a very, very powerful tool to add on all of those layers and to contextualize it into space. Okay, so the last thing that I'm going to do is just to show you, if you want to add some map notes, how you go about doing that. It's really very simple. And just as a guide, I'm going to go down here. I'm going to turn this on. Here the plate boundaries, so we can see where the plate boundary is. Let's come down here where it's nice and simple, nice and easy. And we've got our plate boundary coming across here, and you can see some of the transform faults. To add the map notes, you just simply go add map notes, give it a title. So we'll call this Constructive Margin South Pacific. Let's create that, and then you have your different things you can add, pins you can put on, shapes, freehand areas. In this case, some text as well. In this case, I'm just going to put on the freehand line. So I just draw this over here, and that is my line. So I'll call that, so I can change that if I want. Can add in a bit of a description here, a link to an image that's stored somewhere else. Click on here to change the symbol, and I'm just going to change this to the color scheme that I'm using, which is blue. You can see here that you can change the line width, the line pattern, arrows, all sorts of things like this, and then that's just it. Let's add it on. Now if I want to put on the transform fault here, I'm just going to do it like this. There is my transform fault running across there, and the symbol color I'm using for that is this one, and so on and so forth. So you just simply add these on like that, and you can change and edit them as quickly and as easily as that, and you can add on whatever you want and take and guide your pupils to wherever you want them to go as they're producing or as they're engaging with this map. So that's an example of how just adding on this combination of some of the layers that are available through ArcGIS and some of your own through these map notes, how you can really bring a topic like this to life.